Hey, BB.
Hey,
How are you doing?
not bad, not bad. And you?
Pretty good. I think maybe we'll give it just a couple seconds here and let others get into the room.
Sure, sounds good.
Lots of hellos in the chat. Hi, everyone. All right, let me pull up my screen here. So today, we're going to talk about JetBrains Mellum and the rise of specialized language models. And I am joined by the wonderful VB from Hugging Face. VB, if you'd like to give a quick introduction to yourself.
Sure. Hey, everyone. I'm BB. I'm based in Paris. I work at Hugging Face as the head of developer advocacy and platform. And I've been there for about 3 years. I'm quite passionate about small language models and also just generally the on-device ecosystem, including, Llama CPP, MLX, and so on. Excited to, chat with Michelle today. And yeah.
Thanks so much. We're so excited to have you. We've had such a wonderful partnership working with Hugging Face, and we're just really honored for your time here today. And for all those that don't know me, I'm Michelle Frost. I'm an AI advocate at JetBrains, coming up on month 8, so I haven't been here super long. But Mellum has been really fun because it's the first campaign that I got to work on at JetBrains, and we get to talk about that today. So a couple of housekeeping items before we get going. Let me go to my next slide here. If I can. Okay, so we are recording this. It's going to be available on YouTube. We'll make the URL available and we'll share it on different channels and our newsletter. Also, we will have a hard stop 50 minutes past the hour for a live Q&A question. We'll try and get through as much as possible. Please feel free to add any questions in the chat. And we have a lovely moderator that's going to be sending me questions. Valerie Kuzmina, I must mention her. She's our product marketing manager for AI and has just been the powerhouse behind the Mellum campaign. So thank you, Valerie, for all your work here. And if we can't get to any questions within that 10 minutes, we'll come back and answer them later in YouTube. So what's Mellum? I have heard a couple people call it Mellum on some of the like YouTube channels, so it is Mellum. And Mellum is our tiny 4 billion parameter model that was purpose-built for code completion. And we're going to talk a little bit more about what we mean by purpose-built here just a little bit later. It is multilingual. It supports a large variety of languages. It's been trained for speed, accuracy, usability. It's very small, so it's cost efficient, right? It's energy efficient, it's secure, and it's private. And we're going to go into all of this a little bit further. But the really exciting thing that we just did was we open sourced it on Hugging Face in April. Oh, sorry, I think it was May. My times are a little off. But VB, I'd love to talk to you about that. So from Hugging Face's perspective, like, why would you say that it's important to open source models like Mellum?
I think there's if you look at like the current sort of landscape, right? So there's like giant models, which are potentially either closed source or large, like really large models, like for example, DeepSeek, or closed source like OpenAI, O3, GPT 4.5, potentially upcoming GPT 5, and so on. At the same time, like there are like varying levels of sort of barriers to entry with like each of them. For example, when we talk about like a closed source model, there might just be that that a person which is not based in the US or EU is unable to even be verified to get access to like a closed source model on OpenAI or let's say Anthropic and so on. Then when it comes to, model sizes, if it's like really large model, let's say if it's something like DeepSeek R1, which is like 671 billion parameters, that's not something that you can run on like a MacBook or, just your everyday computer. This is where I feel like small language models come like quite close. To allowing people to still sort of get, say, 80 to 85 or like 90% of the performance of these like large models, but at at a place where they can just run it on device, right? And this is something that would also work on CPU based on like different on device sort of frameworks and so on. So I feel like small language models are here to say, no matter how good or, like even if we get AGI over API, I think we'd still have small models.
Yeah, 100%. And I think you touched on a lot of points too that like I want to circle back to kind of later on as we go. I think I heard points about accessibility, about that, having access to the power of a small language model versus some of like the larger ones that most teams around the world can't afford to have access to. Maybe along those lines, like who do you think, or maybe what kinds of developers or engineers would you say that Mellum is best suited for, or models like Mellum?
I would say, it's a model which should work for any and everyone. More specifically for, you could use it to sort of learn about, even if you're like learning how to code, for example, you could ask it questions about like, hey, like how do I do X, how do I do Y, how do I sort of like edit this this sort of loop. But also for more sort of like advanced people, like who've been coding for a couple of years, this is great because it can sort of edit your code in place and so on, and you can ask it for like super specialized tasks, or just ask it to write like a piece of your code, or like rework some of it and so on. So I would say like it's quite versatile, for like ranges, all from sort of beginner to advanced. It should work quite well.
Yeah, and it's fun how how easy Hugging Face makes it to interact with the open source models. And I just saw in the chat, is Mellum available yet in JetBrains IDEs? So that might be a good transition here to we're going to do some live coding and look at the cloud code completion. So let me just switch my screen here for a second. Okay. So let's live demo, because that always works really well, right? All right, so to answer the question, is Mellum available yet in JetBrains IDEs? The answer is yes. So Mellum powers our cloud code completion within the IDE. And we also have other plugins, obviously Junie and AI Assistant, but we're looking at something a little different. So just to do something pretty simple here, maybe just a ETL pipeline, and what we're going to look for is that cloud code completion. So if we write a so yeah, actually that is exactly what I want. I actually think I want to not quite get there yet. That is exactly what I want here. So that's pretty simple. It's just working alongside with me, right? It didn't go straight for the raise for status, but it's pretty easy. Once I start typing it, it's going to go for it. And then if we wanted to, I don't know, throw this into like a pandas data frame. So pretty simple. We could keep going. We could transform, I don't know, the title length and maybe show the average title length per user ID, but you get the idea. Mellum is what is powering that cloud code completion inside the IDE. So I think that it's pretty nice because it's, what we've been trying to do is create a different flavor of AI integrations, because you've got developers that maybe really want like a light touch when it comes to AI, or even no AI. You could turn this off if you want to, all the way up to sort of your vibe coders. So there's a lot of different profiles when it comes to devs interacting with AI. And it feels like IntelliSense, right? It feels like a natural part of your programming process. Again, we could keep going, but I don't know that we want to sit here and build an ETL pipeline together. So let's talk more about it. And I'm going to switch screens here again. Okay, so this is fun. We have been calling Mellum and its future siblings a focal model. And obviously, we already have the terminology SLM, small language model, right? But we wanted a terminology, a word that would really capture our intent with Mellum. And our intent was that Mellum has a focus, right? It is laser focused on cloud code completion, right? On code completion. It's based off of Llama architecture, and it was trained specifically on data sets that would empower it to do so. There's a little bit of lore behind the term focal model. Maybe we'll give that. So I'm pretty open about this on most of my platforms, but I have epilepsy, and I mostly have focal models, or I'm sorry, focal seizures, which basically is a seizure that happens in a very particular part of your brain. And so while we were sitting in meetings trying to figure out, okay, what is that word that captures our intent here? It's laser focused. It's, oh, it has a focal point. It has a focus. And what we're really intending to capture is sort of that T-shaped skills when it comes to humans, right? So often when you're doing career building or training, we talk about how, you want that breadth of knowledge, right? But then that vertical mastery in one area. And a lot of the large language models that are really generalized, they focus for, breadth, right? They're trying to cover a large domain of generalized areas, but they often lack mastery in that deep vertical. And the rest of this is bloat, right? It's energy consumption, it's expensive, right? It weighs things down, and we don't always need it. We have learned over and over again, which we'll touch on, that small specialized things have historically done very well in the field of AI. And that's kind of what we were trying to capture here too. So I would say, would you think, VB, what distinctions would you see between maybe a small language model or a focal model and other generalized large language models that have been scaled down? Could you kind of tell us how you think of the differences between those two?
Right. So I think generally the way I categorize these models are based on what task do they do, right? So for example, you can have a small model which just does translation, right? At the same time, you could have a small, like a really small model which could just do embedding, right? So which is hyper focused just for doing embeddings. Hence the task specific in this one. And even within, say, a task of text generation, you could have certain specific models. Like, for example, Mellum is one for code generation. Then you could have certain specific for code editing. You could have certain specific for text generation. Some which are now very focused towards MCP, tool calling, and so on. So the way I would sort of categorize these is based on the task. And second would be within the task, what's the subtask, right? So task being text generation, text translation, and so on. Subtask being, in case of text generation, just normal text generation, as in literature, and or with respect to code or with respect to editing, and so on and so forth.
Yeah, absolutely. And that's where we've kind of seen this family of focal models that we, intend to develop onto, where, each one can have that specific vertical, that specific domain-driven task. And I know you've talked a lot about how SLMs excite you. So on the fun side, what are maybe some compelling use cases or things that have gotten you really excited within the small language model space?
Well, I use small language models quite a bit, like on a day-to-day basis. I'm not sure if I mentioned, but I live in Paris right now, and as someone who doesn't speak as good French, like translation is something which I use small language models quite a bit. I have I have a shortcut with Llama CPT, wherein I would just call a small language model, in my case Quen, and also small LM3, and I would just ask it, hey, translate this to English, and it works quite well. I also use really small models for just rewriting text, especially for emails and so on. As someone who's very used to just writing on Slack in a very informal fashion, when it comes to emails, I just quickly would just either record or just transcribe some of the thoughts and just ask it to make it sound good. And recently, I've been playing quite a bit with MCPs, so like tool calling, and I use a few of either our in-house models or some of the open source models to just play around with tools on in my case Mac. So there's an Apple MCP server which helps me add stuff to a note, add stuff to a reminder, add stuff to a calendar, all via natural language, and that's quite fun already.
Yeah, absolutely. Maybe, so you mentioned MCP, and we're not going to get into a full-blown MCP conversation right now. But I still have just been giggling at the joke that's been recycled from IoT days, which is what does S stand for in MCP? And the answer is security. So maybe along those lines, what risks or maybe trade-offs do you see that come with specialization and the small language models?
I guess in terms of security, there is always there's this sort of ongoing debate about prompt injection or sleeper prompts and so on, which is something that is quite hard for you to for an average person to sort of figure out whether or not your whatever language model you're using is sort of secure enough to use that. Just for context, these prompt injections could be that for if you give a certain specific prompt, then that triggers the language model to provide an output in a certain specific format. So an example of this would be let's say you're running a small language model in on your Mac or on your device, and you ask it to generate certain specific bash commands, and on a certain specific input it just generates rm-rf for whatever directory, right? That's a very sort of it's quite a plausible sort of output. And if you don't have any guardrails on top, or if you're if you're not on the lookout and you're just running it on YOLO mode, just full agent mode, just letting it do its own thing, then it could potentially be quite disruptive, right? At the same point, moving to sort of less grotesque sort of issues, it could be that if you're asking a model to sort of rewrite something, it could be that it hallucinates a bit. So in case you're working on really sort of regulated industry, or if you're working on something legal, then you really want to know what your model is changing, right? So having some sort of a as you can in, for example, JetBrains as well, or in the IDE, you can look at different sort of, you can see what has changed in the file from one to the other using the Git syntax and so on. So I think there are certain there are these sort of nuances to sort of small language models. At the same point, I would still prefer these over APIs and so on. Because as someone who also consumes like OpenAI API or like Anthropic API, I'm just never sure whether or not, like, if a request I send to them, if I would actually get a response out of it. And like there are so many such sort of cases wherein um, any of these sort of closed source providers, it could be that they are quantizing the model behind the scenes, or they have like a smaller model, they have swapped something, and so on. And there's no real way for you to like check, like in case of sort of small language models, or like just any language model that you can download from, say, Hugging Face. You have like a MD5 hash that you can just compare, like this is what you see is what you get, right? And you kind of like sort of own the weights. So yeah.
Yeah, no, I totally agree. It's definitely like, I think still, we'll talk about this, but it's it's still, you have to know the right tool for the right job. That will always be the answer. Maybe before we move forward into this next section, who do you think benefits the most from focal models, from small and specialized language models?
I think the community benefits a lot, right? And also, like, if you look at the vertical of like researchers, labs, and just like sheer competition, wherever there is competition, like like the community always wins, right? As you go with respect to model sizes up, so be it from like fully open source and like open weights models, as you go up, like you see that closed source sort of players start to sort of edge a bit or like win a bit. And as you go down the vertical, like of course, like you lose quite a bit of flexibility and so on. But at the same point, like when it comes to like focal models, or like small models in your case, it's like the community wins. Like every week, every month, there are like new players in town. Or like for example, like you released Mellum. Like I'm pretty sure, like couple weeks, months down the line, you might release like a newer version of it, or like more task specific version of it, for language specific versions of it. So and at the same point, like there might be researchers, there might be fine tuners, and like the community is also like constantly trying to make it better, right? For example, when the model was released, like there wasn't a Llama CPP support, and then within the next day there was a Llama CPP support, and so on. So like I think the community wins in like pretty much any scenario in this case.
Yeah, totally. I think like the same for me is access, and kind of changing that global power dynamic and landscape. And I think for me the most exciting is access to researchers, especially people that are looking at AI within different intersections. So for our use case, software development, and what does that future look like, and how can we create metrics around it? Well, you have to be able to access a model, right? And if you didn't have models like Mellum, small open source models, they wouldn't, be able to go deep into that empirical research, or rather, it would be very limited as to who could do that. So I think maybe let's just chat for a little bit. I'm going to turn my slides off briefly here. Okay, let's have some fun. I feel like I've noticed a big shift happening honestly, we've been in cycles of shifts happening, right, since 2022. This wasn't exactly the future I had imagined, 5 years ago when getting into machine learning and AI. But it feels like maybe the hype bubble is finally kind of starting to pop. Do you feel like we're at another inflection point in AI, and do you think that part of the shift is moving towards small and specialized models?
I feel like there's room for both, right? Like I mean, I feel like when it comes to when it comes to specialized models, we'll continue seeing like a lot of improvements, and just generally like better post-trained models, more capable models, and so on. At the same time, like when it comes to closed source models, or just like larger models, I feel like they will continue pushing the frontier forward. And And I can imagine, much like now, like we will continue to see like a more sort of clear bifurcation of these two sort of sizes of models to sort of coexist with each other. One's a generalist, whilst one's a specialist, right? And there's room for both. Um, I do think like as we get into the nuances of stuff like EU AI Act or like the US AI Act and all of these sort of like sovereign nations trying to sort of figure out like what's the future and like parse the future of these models, and well, the community as well as like the populace sort of coexisting together, we will see like more push towards open weights, as we also saw with the recent sort of like US AI summit as well. That if you have like the weights in hand, you can audit them, you can see like what exactly is it, and it won't just be about like East versus West, but more specifically about like model weights that you can audit, right? And then again, like there's sort of in the spectrum, like both specialized models as well as like large models sort of coexist and so on.
Yeah, I won't make myself tap the politics sign, on me, but it's interesting to me how much of like the geopolitical landscape comes into play in AI, and it is about access, it is about power, it's about control. Again, I'm going to not tap the sign, but I, had a couple eyebrow raises over, recent legislation that's come out from the West, where I am, and it's going to be interesting, to watch. And I think, to your point too about fitting these things together, fitting in small language models and the large language models, like there seems to be this broader ecosystem, and those hybrid approaches to me are really interesting. At the risk of saying something kind of cheeky, I've been, thinking of like small language models sort of as like the microservices of AI, right? Where we can kind of have, okay, you've got a task here and you've got a task here, and they integrate. And maybe that one of the handoffs is for a proper large language model, depending on what your use case is. What do you envision about like that future ecosystem with these combined approaches?
Definitely. So back maybe like a year ago, like Apple came up with this analogy of Apple Intelligence, which sadly it has failed to deliver on. But the idea behind it was something which has still like stuck to me, which is that based on a particular request, like you can figure out which model to route your request to, right? So for example, if someone is asking for just to translate X to Y, you can just you can route it to a specialized model, or in their case, they had like specialized LoRa's for this specific case, or like if you're unsure about like where to send a request, like which specialized model to send a request, you can send it over to a large model deployed over their cloud, right? And I feel like we're gonna sort of like converge to a setup like that, right? There is a really nice open source project called Minions, which essentially does the same thing, which is like you can based on a particular request, like it tries to sort of figure out which model is better for what, and it could be like, for example, you could at some point, I don't find it quite hard to quite as dystopian, that we might have specialized model for Python, specialized model for Rust, specialized models for JavaScript. This is just in the coding realm, but at the same point, you can have like specialized models for I don't know, making SVGs, or specialized models for React and like stuff like that. And I could see that sort of play quite well with this like setup of like using specialized models. Lastly, like something that I have been experimenting a bit recently is to use some local coding models to execute, but at the same point use really large models, potentially closed source as well, for making a plan of what the small model should do, right? So a larger model can sort of create a plan, smaller model can sort of execute. And I can see like this space be a bit more disrupted by plans like those.
Yeah, totally. I think you touched on things too that I've seen some questions circulating in the chat that are super related, and I'm certain those people are like, are they going to answer the questions? We will come back to those specifically. I think the React and Python pieces that you mentioned, I've seen some direct questions related in the chat, which we'll circle back to. I also saw the message that I dropped my mic. I'm not sure when that happened, but I hope that everyone could still hear me. It was a literal mic drop from apparently a magnet fail. So, whoops. So, maybe we'll talk just briefly about some historical context and framing, right? Because, large language models are new-ish. Attention from the Attention is All You Need paper, for those that aren't familiar, that introduced transformers. That was 2017. And then obviously ChatGPT was released in November 2022, and that's really kind of changed the landscape a lot. And now pretty much when everyone's talking about AI, they're talking about language models. But that hasn't always been the case, right? We're actually this year, I need to put a calendar reminder for myself, but we're actually going to have the 75th anniversary of Alan Turing's paper, Can Machines Think? So if you think about that, that's 75 years, right? Decades of iterative nature in machine learning since the 80s of making these iterative improvements, right? And we've kind of seen a few different waves of true progress. And I think if we kind of look back, like there's, to me at least, a recurring theme that bigger isn't always better, right? And it's held true in the past. I remember in grad school, I had a professor that was always drilling in the no free lunch theorem. Every single answer to every single question he provided was, well, there's no free lunch. And if you're unfamiliar with this concept, it's basically like, there's not one model to ever solve every job, right? You need to understand your problem. You need to understand the context. And then you have to know what your tool is for the question or the job that you're trying to solve. So, on that wave, like where maybe specifically, maybe we can even gear it towards NLP, natural language processing space. Like, where have you seen this hold true in the past?
Right. What specific?
With the bigger is always better, or even like on some of that, like the iterative nature. I don't know. Maybe we even pull up like Word2Vec as an example there.
Right. I mean, I think if we just look purely from like natural language standpoint, like of course, like the start of these sort of like LMs could go back to very simple sort of TF-IDF vectors, right? Which is like term frequency inverse document frequency, wherein you just throw like a bag of words and you try and figure out what's the probability of this word coming next to whatever is preceding. So if I say hello, what's the probability of world coming next to it? And you just create like a really large matrix of like all the words in whatever corpus you feed it to, and then you sort of like use those probabilities to then do a thing X with it. It could be like predicting the next word, or it could be just fixing spelling mistakes. Could be a lot of things. From that era, like we went to Word2Vec, wherein like you just have the same sort of principle, but you apply it with like one very simple multi-layer perceptron. Actually, in that case, it was just a single layer perceptron, right? And you use a model to sort of use the weights literally to sort of figure out these sort of combinations and like what goes well with what and so on. And that was kind of like the spark which like led to then like using RNNs, LSTMs, and later on like transformers, which was the case with sort of BERT, right? And when BERT came out, that was like one of the first sort of like scaling studies that you can just like 10, 20, 100x the amount of compute and just throw at these models, and specifically like in this case transformers, like type architecture can just like learn with it. In fact, not just learn with it, the more data you give it, the better they become, right? And from there on, like rest is history, right? Like even within BERT, like then just trying to sort of fix BERT a bit. Sorry, I actually had a call and I lost the chat. Sorry. So just trying to fix like BERT a bit, like there was Roberta, then there was dBERTA, like all of these sort of like tweak either the architecture a bit or just like, scale the model with respect to data set a bit and so on. And also in some cases, tweak the training objective itself. And like we've been seeing this like all across. Like now we see that like the community has or like labs in general have sort of like converged over to transformers as an architecture, and there's like a lot of sort of work being done on essentially making them faster, making them better, making them more compute efficient, making them more token efficient, and so on, and so forth. Like and I feel like what we saw was that before we had these sort of like specialized sort of use cases for all of these models. Like we had, you can use RNNs for translation, you can use CNNs for like vision stuff, and so on and so forth. But now we're seeing that you can just throw transformers and you can just throw more layers at a given function, and it will just become better, right? The Like if this trend continues, and as it is, what's happening is that it was just text only before. Now you can throw like text and vision together, you can throw text and vision and audio together, and in fact we have like true sort of end-to-end models which are like across all modalities and so on. So yeah, so essentially like the trend that I'm observing is that you can just throw data, as long as it is paired, as long as it is like transformers as an architecture, it would just continue to scale. And that's what a lot of sort of like labs are betting on.
Yeah, it's the historical piece and kind of like that iterative nature has always been very fascinating to me. Last year I read Dr. Fei-Fei Li's book, The Worlds I See, that came out last year. I don't know if you had a chance to read it, but it was really interesting. So, obviously she pioneered a lot of work in computer vision, right? And, CNNs. And it was kind of funny to me towards the end of the book, she starts kind of name dropping. There's some names that we know very well, and the intersection of these different spaces of NLP versus computer vision, which used to be very separate, and where they started intersecting and where they started kind of learning some of the same tactics. And now, like you said, we're entering into this space of multimodality. So we're able to throw all sorts of audio, visual, text input, which is a lot closer to how human brains work, right? Like we're receiving all sorts of inputs simultaneously and processing them together, which I think is very interesting, just seeing where that will go. But also there's just, to me, without, diving down the AGI path, there's still so much there that we're just not covering. But from a multimodality standpoint, it's super interesting. So I have seen a lot of questions kind of pop through the chat. I'm just kind of keeping an eye on it. And I think there's a lot of questions kind of about the dev ecosystem and, how we enable some of these models. So maybe we'll talk tooling for just a little bit. Like what would you say is making it easier right now for devs to build and deploy small language models? Any like trends that you're noticing?
Right. I mean, I think so. Just some historical context. When Llama as an architecture dropped, right? It was the first sort of proven architecture which scaled not just for text, and now we're seeing that it scales for vision and also for audio, wherein you just change the tokenizer and you get like the same-ish results. But when like Llama as an architecture dropped, we saw like this like huge sort of uprise of fine tuners, right? Who would just take like a language model, which was definitely compute efficient, but was not so much like token efficient. Just wasn't specialized enough. So we saw like this like rise of like people fine tuning these models for their specific use cases. It could be for Python, could be for role play, could be for creative writing, could be for like a lot of different things, right? Could be for playing games, and so on. And this was of course like powered by a lot of sort of like Hugging Face libraries, or like libraries built on top of like Hugging Face ecosystem. So for example, like people would use TRL, which is a library for fine tuning, or of course they would use it with transformers, or they would use like stuff like Unsloth, which is again built on top of sort of TRL and so on. And the idea here was that you sort of like use like a already good sort of base, and then you try and sort of create a better sort of model uh, out of it, right? um, and like from there on, at like an architecture level, like we see like outside of maybe like MOEs, which is essentially like mixture of expert, wherein like you instead of using all the model in one go, you try to route the model through like a small subset of sort of experts, which reduces the overall time it takes for you to get a generation. Outside of these two sort of like broad architectures, we haven't really seen like much changing across like the architecture layer. There are of course like some players like Liquid AI and so on, which are doing some sort of like hybrid architectures and so on, but the architecture layer sort of remains the same. um, I'm sorry, I have to be honest, but I forgot the initial question.
Gosh, I feel like I kind of forgot it too, but because I'm just vibing with what you're putting down. We're talking about dev ecosystem and just
Yes.
what kind of trends we're noticing, and what's making it easier for engineers to kind of develop their own.
Yes, so sorry about that. But then like it's essentially like these two architectures sort of like then like enable a lot of use cases. Like for example, Mellum is also like sort of like based off of like Llama architecture, and like now we have like such a strong sort of model which is now powering potentially millions and billions of IDEs across like MacBooks, laptops, for a lot of sort of use cases, right? And like people. And with respect to trends, like of course, like now we also see like some people using extensions and so on to use like small language models. Sometimes use large language models. I feel like that trend will sort of continue. Like we see people, like these extensions like Roo Code, or there's Klein, there's people just using Llama CPP to potentially deploy Mellum, and then just use that within some other IDE that they use, or something like that. At the same point, I feel like now the models are so strong that, let's say you tomorrow want to build a framework, and you build this framework and you want a specialized model for this framework, you can just sort of generate like 100 to 200 sort of samples and just fine tune this model for it. I think in the comments, Paul had this sort of question: is like what do you do when like these like, let's say like we're talking about f strings in like Python, and let's say you're talking about a model which hasn't seen f strings in Python, right? Now like the model does not know like what f strings are. So if you wanted to sort of if you want to teach it like what these f strings are, you need to sort of train this model, right? And because now like the models are so like sort of token efficient that you can just give them like 100 200 samples, and you can just fine tune them, and you can just make them better at Python 3.14 or Python 3.15, right? Or like the latest version of whatever JavaScript flavor they're using. So just wanted to point that out.
Yeah, I know Paul is ecstatic that you answered that question. So before we get into questions, there are two kind of things from Hugging Face that I wanted to touch on. So the first, I'll pull up my screen here. Every time I just want to be like, oh, it's small LM3. But I know that you've worked on this. So do you want to tell us a little bit about this? This article just came out earlier this month. And this is, obviously very exciting. I think a lot of people have been interested and been using this, but I just wanted to open up the floor to you to talk about this.
Sure, yeah. It's one of the projects which, like within Hugging Face, we we feel quite strongly about. It's a For context, it's a fully open source language model wherein we open source everything right down from training scripts to inference scripts to training data to intermediate checkpoints. And like we, if someone wanted to sort of create like a language model from scratch, they can use that and essentially come up with like small LM3, right? But and also like make it better. Small LM as a family of models has been around for a while, right? So we had small LM1, we had small LM2, and this one is small LM3. These have been these are not like the same models as, they don't compete in the same space as, for example, Mellum, right? Like Mellum is like a highly optimized, specialized model for coding. Whilst like small LM3 is more like sort of like a general model. It's small, it's multilingual, and it has like incredibly long context. Which means you can use it actually for the use cases that I was mentioning before, which is, I want something to just play around with like MCP things on my local laptop, or I wanted to sort of translate things, I wanted to fix my language, and so on and so forth. um, it's a it's a model which is built off of the like existing architectures like Llama, but with a few sort of architectural changes to make it more sort of compute efficient, and like sort of just like be more sort of integrated with the open source ecosystem. It was trained from scratch. And yeah, it's something that the community loves quite a bit. We are spinning it like we within like small LM as an ecosystem of like models. We have sort of general purpose VLMs. It's called small VLM. Maybe potentially we would have like an audio model based on small LM3 quite soon as well. And yeah, just generally, this as an ecosystem of models can be used on web GPU, like with on like browsers and so on. So yeah, do give it a shot. I would not take like credit for like all the work that the team did for like small LM3. I was just involved in like making sure that these models sort of work on device frameworks and like adding support for those. But the team really like as the cool kids now say, cooked with this model.
Yeah, I'm excited. I've got a couple ideas for it. I won't spoil them here, but maybe we'll sync back up in a couple months. So one other thing, I promised a hard stop at 50 minutes past the hour, but I did want to bring up one other thing that I think has been tying a lot into our conversation here. Oh, come on, here we go. So this paper came out a couple months ago. I know Dr. Sasha Lucioni from Hugging Face was working on it. And the long title, Bridging the Gap, Integrating Ethics and Environmental Sustainability in AI Research and Practice. And I thought that the paper made a few really interesting points that we often talk about, ethics, including fairness, transparency, explainability, as a separate conversation from sustainability. And I think a lot of times when you talk about sustainability, people immediately think of, energy consumption, carbon footprint. But there's more to sustainability than that, right? There's that access, there's the accessibility, piece that we've mentioned. There's the power component of, making sure that smaller teams, or even, from a global standpoint, that it's that we can enable access more broadly, because a lot of these large language models, for example, that were built and trained in the West might not be applicable to everywhere else in the world. So I'm wondering how like small language models tie into this conversation, into this research. Like, do they change how maybe we approach topics like transparency and model evaluation and that connecting piece to the sustainability? And like how, from your perspective, they reshape who gets to build and benefit from AI?
Yeah, I think there are like multiple sides to this, right? So maybe like just trying to sort of start with like the ethical side of it, which, by the way, like there's no right answer. There are like different point of views, right? Like we don't have a consensus on like we do have broad consensus on like what is good, what is bad, but like there's like such a huge gray area when it comes to like ethics or like sustainability in general that there's no sort of like right answer to it, right? But like if we just talk about like ethical side of things, right? There are multiple schools of thoughts. Like for example, if you send a request to sort of like let's say Anthropic, then like Anthropic decides whether or not your request fits their model code or not. If it fits their model code, they will decide to sort of serve you, right? But if not, then they would just say, hey, this does not work with us, like we're not gonna entertain your request. At the same point, like, you know, if you have a small language model, you can either like fine tune it to your specific use cases, or you like, even if like whatever it may be, there are no like you define like how the model is going to be. So the moral code of the model is decided by you, right? Not by a third party which can change at whim its policies, right? This again could be good or bad, right? um, but we now know that like humans are much more capable of like, you know, setting and like sort of like resetting their sort of moral compass, that you can trust them with like, you know, things, um, again to a certain degree. Then comes, you know, the whole sort of like the whole sort of like side effect of like, let's say that we have all of these like models, like now like every lab wants to build like the next largest model out there. Then like this comes at a cost, right? Like you like not everyone has like, you know, 600,000 sort of H100s lying around, and you cannot just like sort of like create a really large model and then just, you know, just like put it on the shelves, right? This all comes at like a really huge sort of like cost to both the environment as well as like you know, electricity. Like for example, like if you're training something like Grok 4, Grok 3, back at like XAI offices, like they have a pretty huge sort of cluster, and these clusters like require quite a bit of sort of energy. And like there were some news and like rumors around like them sort of be powered by gas turbines and so on and so forth, which of course like in turn like sort of results in um, you know, pollution, whatever it may be. Like, you know, like it's not good for the environment, right? So small language models on the other hand are quite fit for these use cases. You can, you know, like with maybe like 1 hour on an H100, you can get a specialized model out, right? Or like, you know, you can just like you can run like a Mellum on your device. You can, in fact, in some cases, if your device is capable, you can just run it on a browser, right? Which means that the model itself does not take any more compute than it has to um, on your laptop, right? So you're not really like sort of like spinning up like a virtual machine somewhere out in a data center, which is like powering it, and like then, you know, you're using energy to sort of cool it down. Um, all of that is sort of like reduced. So I do feel that, you know, small language models are like a good trade-off. From like 1 year back from to now, like we have much more smarter like small language models which are really good at what they do, and in most cases they are like 95% there to where like frontier models are. So yeah.
Yeah, no, I think you touched on so many points, and like I could, you know, chat in just this space with you for another hour, but it is interesting. It'll be interesting to see what comes out of this space. I think you said it perfectly. You know, we have the value alignment, you know, problem in AI where, you know, for every value that someone holds, there's an opposite argument on the other side, and both sides are valid. And how do you, you know, find compromises in these large language model spaces? I did see, I've seen a couple articles. I haven't been able to read the paper yet, but the highlights were that I think it was Switzerland developed their own like ethical language model. So I'm curious to dive into that. But then, you know, as you said, it's like, okay, well, when is the opposite of that coming? So, you know, we'll see. But I want to be respectful of the time and for questions. So let me just kill my screen here for a second, and then we can go through our questions here. So So let me just scroll back up here. I think you answered Paul's question, who has been working on 3.14. So he's, I'm sure, very excited about that. And I think another related question was, someone said, is Mellum the right tool if you also want to, say, generate a React component? Like, yes, it's going to code complete, with TypeScript and JavaScript. So that is, included within that. Trying to sort through your questions. So we had another question. How does Mellum code completion score stand with other models, both small and large language models? So we do have the scorecard on the landing page, and also we've released it in a couple blog posts. Keep in mind that there's a difference in size, and so there's context matters to that. Sorry, I'm just reading here through. Are there any docs how to fine-tune Mellum on my own source code so it would provide better autocomplete? We haven't released any docs, but as we've mentioned, it's Llama architecture, so there should be a lot of information out there. VB, do you want to give the kind of half pager on if someone had, maybe let's say if someone has never used like the transformer library or interacted with any sort of open source models on Hugging Face, like what would you tell someone?
Right. So I would say go on hf.co/learn, which is where all of our open source sort of educational material is. And within that, there is a LLMs 101. Go there, and there is an entire there's an entire sort of 1 or 2 day long sort of chapter on how do you use these language models, how do you fine tune them, and we also walk through use case wherein you can just fine tune it on a free Google Colab. So I would say go there, but just generally transformers as a library is the way that you sort of define a model and you sort of run a model, right? So you can run inference on a model. And then you can go one step ahead, is you can fine tune these models on your certain specific use cases. You can run evaluations and so on and so forth. Then there are specialized library like TRL and PEFT, which allow you to sort of fine tune these models just by essentially defining a configuration of what you want this fine tuned model to look like. This configuration would be I want to pass this data set. I want to, this should be the learning rate of my fine tuning. This should be, and a couple other things. If you don't know those, you can just leave the defaults be. They're pretty educated defaults. And then after maybe half an hour or an hour of training, you will get a fine tuned model, which you can then use. Then there's library like PEFT, which allows you to do it. All of this in the same sort of way, but in a more compute efficient way. So that's the TLDR.
Yeah, no, that's perfect. I think in the interest of time, what we'll do is circle back to some of these JetBrains specific questions, in the YouTube chat post live stream. But the most recent question here, VB, is for you. So while we have you here and have your time, it says, you mentioned that in some cases an SLM can be trained in around 1 hour on a V100. Would that apply to small LM3?
Definitely, yes. Just a quick sort of nit, it's not trained, but it's fine-tuned, right? So training in itself, for example, for small LM3 took I don't know, something like a month or two over a really large sort of cluster of H100s. But for fine-tuning, you just use the same base, and you can reasonably sort of train it to a certain degree on with 1 hour. Or an hour and a half on a V100, T4, L4s, and so on and so forth. In fact, it works on a free Google Colab as well.
Thank you. I want to be mindful of the time and your time. We're so appreciative of you joining this. And again, if you dropped a question in the chat or you want to add one further, we'll come back and circle back to those. But I think we could keep talking for another hour. I think it's close to 7 p.m. for you.
Yes.
And it's just barely lunchtime for me. So I'll let you go. But VB, thank you so much for joining us. And, maybe we'll have to keep it going another day.
Hey, thanks a lot. Yeah, it was a pleasure. And yeah, if anyone has any questions, feel free to DM me on LinkedIn, Twitter, whatever it may be. And have a great rest of the day. Bye-bye.
Thanks, VB. Thank you, everyone.